Hello everyone, my name is Deep. Welcome to DeepWorks. In this video, we are going to explore how wait notify activity works in TIBCO BusinessWorks Container Edition. Let me share my screen. This is TIBCO Business Studio for BusinessWorks Container Edition, which is used to design and develop projects. This is a project explorer. For this video, we'll try to import an existing project. Right-click, import existing studio projects into workspace. Click on that option and choose the path where the projects are available. Click Browse. BusinessWorks Container Edition 2.9 samples, app space, palette, general activities, wait notify, and this is a sample project that is available. Click Finish, and this will import the project into our workspace and expand processes folder. We have two processes. Once we double click that process, we see the process canvas, and this is where we can design our process flow. It is a timer-based starter process, which is writing log, wait notify log, and input is main process started the main process and main process spawning non-inline subprocess. Non-inline subprocess is something which gets executed in a separate thread, not in the same thread as the main process. That's what it means. And we have this log activity which logs the same message. And then this is the subprocess which is spawned, which means that it will create a new thread and execute in a new thread. And once we go inside, this is the subprocess, which is having some business logic inside this, which we will get to see just in a minute. And once it's executed, the next activity is again a write file, which says main process waiting for the notification, and the log, which again logs the same message. And here we have the wait activity. And this wait activity will wait until this call process execution is completed. That's what it does. And if we see the logic inside this subprocess, we have a start activity. We write to log, and the message is like subprocess, inline subprocess started. And then we log the same message. And here there is a sleep activity, which is having a 2000 millisecond, which is 2 seconds of sleep. This sleep activity is actually mimicking some real-time business logic, which takes two seconds to complete. And we have to wait for this business logic to be completed in order for our main process to complete. And here is the notify activity, which will notify once this business logic is completed to the main process, so that the process execution is completed end to end. So there are certain key things we have to pay attention. Once the notify is completed, it says notification sent to the waiting activity, and it writes the same log and then ends the subprocess. That's when the wait activity completes. And then we have a log message saying main process notification received from the other process with the data, and we have the result which is mapped from the wait activity. And then we have a write file activity which writes the same message to the log file. Here there is a message saying activity waiting to be notified for the same key. What is this key? In real time, this main process will receive several incoming events, and this process is executed several times. So how does one process instance knows that this subprocess has to notify the same main process? That is the key, right? So we have to send the input key to the calling process, which is the process instance ID, which is unique for each process instance that gets executed in real time. And this is sent as the key to the calling process. And in the wait, if you see the configuration, we have the key field, which is mapped from the start key, which is the process instance ID, and the notification timeout is 10,000 milliseconds, which means that the business logic, if it is taking more than 10 seconds, then the process times out and the execution completes without processing the actual business logic. And here again, the wait activity will be mapped with the same process instance ID so that it correlates the output coming from the calling process with the main process. And the timeout is again set to 10,000 milliseconds, which is like 10 seconds. Let's try to run this example so that we understand how it works. And I just wanted to increase the timeout a little bit because we will not be able to see the difference if it is just 2 seconds. So I will increase it to 20,000 milliseconds, which is like 20 seconds. And if my business logic is taking 20 seconds and I have a timeout of 10 seconds, I'm sure that we will not be able to finish the business logic and complete this process end to end. So I will increase this notification timeout to 100 seconds. We also need to increase this in the wait activity because we have to wait until the business logic is completed, which is taking 20 seconds as we know. So I have increased it to 100 seconds. And here there is a bug icon, which is used to debug the project, and click on debug configurations, which will open the debug configurations window. And we have selected the processes which needs to be tested and click debug. It has changed the perspective. Up until now, we were in design perspective where we design the process. And when we wanted to debug, it changes to the debug perspective, which will have different windows open for us to better understand the debugging. And below is the console where the process is getting executed. So here Right now, I have executed and we are exactly waiting at the wait activity. Okay. I should have increased sleep timeout a little bit more so that we could. I'll increase the sleep timeout to 60 seconds. And we already have the wait activity waiting for 100 seconds, so we are good there. Now, let me debug this application again. Here is the console log, and okay, the main process started execution, and if you see, the main process is stuck at wait activity, and the subprocess is at the sleep activity, which is just mimicking the business logic. And in our case, it is going to take 60 seconds. And once 60 seconds is completed, the sleep activity notifies the main process, and then wait activity will be completed. And we will see that just in a minute. Okay, 60 seconds is completed, and once the sleep is done, it will notify, then write the log and ends the subprocess. That's when wait activity kicks in, then completes the log and write the log to the file. We can also validate whatever is logged from the console. So here, if you see this line, this is when our BW application started. And then our first log activity is from the main process, which states that main process started, and it is also spawning non-inline subprocess. And once that is done, this is a separate thread, so it will go ahead and log the next message, which is activity waiting for the notification. And this log is coming from the subprocess, which says non-inline subprocess started, and this is what is logged after our sleep activity, which is notification sent for the waiting activity. Now, let's focus on what happened in between. So there is a sleep activity in our subprocess. And the sleep activity time is 60 milliseconds, it will sleep. And if you see here, the timestamp when the process is executed, it is 5:43, and the next log after the sleep is around 5:44. And This means that there is a 1 minute delay or sleep between the first log and the second log. And once the notification is sent to the main process, again, the main process states that a notification received from the other process with data, and the result is mapped, and this is the results sent from the notifying process. This is actually mimicking some results being sent from the sub-process from the business logic that is executed, which takes 60 seconds. And if you see the time again, it is 5:44, which is like 1 minute after we started the process execution itself. And this is what I wanted to show in this video. And I will come up with another video with another activity. And thank you.